curve C has the equation y equals 2x minus 8 root x plus 5. We need to find dy by dx, giving each term in its simplest form. First thing I'm going to do is rewrite that root x as x to the power of 1/2. Now we can differentiate, so dy by dx is equal to 2x, will differentiate to be 2, the 8x to the power of 1/2, so 8 times 1/2 is 4, take 1 away from the power, so the half becomes minus 1/2, and the 5 will differentiate to be 0. So that's my answer for part A. We're now told that the point P on the curve has got x coordinate equal to 1/4, and we need to work out the equation of the tangent at that point. So tangent, I know straight line, so y equals mx plus c, and if I substitute the x coordinate in to my gradient function, that's going to tell me the gradient of the curve at that point, and therefore the gradient of the tangent at that point. So if I do that, the 1/4 to the power of minus 1/2 is 2. The 4 times the 2 is 8, so the gradient there is minus 6. So I can say y equals mx plus c. I now need to substitute the coordinates that this line goes through. I know it passes through the x coordinate 1/4, but I'd like to know what the y coordinate is when x is 1/4. So if I substitute 1/4 in here, that's going to tell me what the y coordinate is at that point, which is 1.5, or 3/2. So if I substitute this coordinate in, 3/2 is equal to minus 6 times 1/4 plus c. The minus 6 times 1/4 is minus 3/2. So if I add that to both sides, I get 3/2 plus 3/2 is 3. So my c is 3. And the equation of the tangent is minus 6x plus 3. So that's my answer to part B. Then part C, we are now told that the tangent to the curve at point Q, so a different point now, is parallel to this line. So parallel means same gradient. So the tangent has got the same gradient as this thing. So what I'm going to do, I'm going to work out the gradient of this line by rearranging this to be in the form of y equals mx plus c. So I've added the 3y to both sides, and then I'm going to divide both sides by 3. So now I can see that the gradient of this line is 2/3. Which means the gradient of my tangent has to be 2/3. To work out where that tangent is, I am going to take my gradient function and make that equal to 2/3 to find when does that gradient equal 2/3. To solve this equation, I don't like this x to the power of minus 1/2, so I'm going to move that back to the bottom. And actually, I'm going to rewrite it as a square root, like that. I'm going to times through by 3, because I don't like this fraction here. So if I times both sides by 3, this will become a 6, and this will become a 12. If I subtract this 2 from both sides, and then multiply through by the root x to get that off the denominator. So I get 4 root x minus 12 is equal to 0. So 4 root x is equal to 12, root x is equal to 3, so x is 9. That's the x coordinate of point Q. And to work out the y coordinate, because it's on the curve, I can substitute it into the original equation. So y equals 2 times 9 minus 8 times root 9 plus 5. So 18 minus 24 plus the 5 is minus 1. And that is point Q.